9-5 multiplication with addition or subtraction. So we're still going to use the addition method for systems of equation. However, we're going to have to manipulate those equations a little bit before we cancel them, before we add those columns. If we look at this example, we have 4x minus 5y equals 23, 3x plus 10y equals 31. And we notice that neither of the columns can cancel. The x's don't cancel each other, and the y's don't cancel each other. So we technically can't use the addition method. It's not very conducive to use the substitution method either, because neither of the equations are isolated for a single variable. However, if we look at that y value, we're kind of really close. You have negative 5y, positive 10y. Well, if I'm only times 2 away, so what I'm going to do here is I'm going to multiply that top equation by 2. And when I say I multiply, I'm going to multiply everything in that equation by 2. And that'll produce an equivalent equation. So if I multiply it by 2, I get 4x times 2, which is 8x. I get negative 5y times 2 is negative 10y. And I get 23 times 2, which is 46. We bring over the bottom equation because we're not going to manipulate it. So it continues to stay 3x plus 10y equals 31. And now, if we combine the columns, (8x) and 3x makes 11x. Negative 10y and positive 10y cancel. And then 46 and 31 makes 77. So we notice that we've been able to eliminate one of the variables, and now we have a single variable. So we can isolate for x, divide both sides by 11, and we get x equals 7. We're going to pick one of the two equations. Technically, you can use any of the four. You could use this equation, this equation. You could even use the manipulated equation. I'm going to stick with one of the equations, one of the original ones, because I know that those aren't wrong. I haven't made a mistake because that's what the book gave me. So I'm going to choose the top one, and I'm going to plug in 7 for x in the equation. 4x minus 5y equals 23. So I substitute 7 in for x. I'm going to start simplifying. 4 times 7 is 28, minus 5y equals 23. We notice that we only have one variable again. We're going to subtract 28 from both sides. We're left with negative 5y equals negative 5. Divide both sides by negative 5. And we're left with y equals 1. And my solution is 7, 1. My x value is 7. My y value is 1. And that is the system, or the solution to the 2 equation. It is the only true value. It's the only value that is true for both equations, for this equation and this equation. If we plug in 7, 1, in the top equation, we get 23 equals 23. If we plug in 7, 1 to the bottom equation, we're left with 31 equals 31. The next problem that we have is, now we notice that it's far more complicated. We have fractions in it. And so my initial reaction would, hey, let's get rid of the fraction in the numerator, or in the denominator in the first equation. So what would get rid of the fraction in the top equation? Well, if we multiply everything by 3. If we multiply everything by 3, this produces 5x, this produces 3y, this produces 21. If we look at the next equation, our denominators are 4 and 2. So we want to find the least common multiple of 2 and 4, which would be 4. So we'll multiply everything by 4. 4 times x gives me 4x. 4 times y over 4 gives me y. And 4 times 7 over 2 gives me 14. Now that's good in the sense that we got rid of our denominators and the fractions, and we have a nice clean equation. However, if we look at our columns, we should notice my x's don't cancel and my y's don't cancel. So I would need to, again, manipulate that equation one more time. But notice that I was kind of close here. I have a positive 3y and I have a positive y. If I could have somehow made that y end up negative 3, then I wouldn't need to manipulate it. So if I can do a better job of choosing numbers to multiply, so I'm still going to multiply the top by 3 to produce that 5x plus 3y equals 21. However, if I think about it, what number would make this y, this one down on the bottom here, this y, a negative 3? Well, if I multiply it by negative 12. Negative 12 times x gives me negative 12x. Negative 12 times y over 4 gives me negative 3y. And negative 12 times 7 over 2 gives me negative 42. Now it's good. Now we're able to use the addition method. My x's don't cancel, but this time my y's do. I have a positive 3y and a negative 3y. So that will leave me with negative 7x equals negative 21. Divide both sides by negative 7, and I'm left with x equals 3. I take that value, that x value, I pick one of the equations. I can take any of the 4. I'm going to take this one because if my x value is 3 and goes in, it's going to cancel with that denominator 3. So I plug it in. I get 5 times 3 over 3. The 3's cancel, which leaves me with 5 plus y equals 7. Subtract 5 from both sides. Y equals 2. And my solution is 3, 2. The final example that we have to look at, and we're going to look at the written exercises. If we look at this, if we look at number 10, okay, what do I want to cancel? Well, I kind of want to cancel the c's. If I multiply everything by negative 3, I can get rid of my c's. If I wanted to cancel out the d's, I would have to multiply the bottom equation by 4. So we can choose either one. This is the nice thing to see knowledge and if you understand it. If we're going to get rid of the a's, I'm going to multiply the bottom one by negative 3. If I'm going to cancel out the b's, I'm going to multiply the top one by 2. Where's a good one? Here's a good one right here, 22. Sometimes we're going to have to multiply both equations. So in 22, if I'm going to get rid of my x's, I'm going to multiply the top by 3 and the bottom by negative 4. So some of these equations you're going to have to multiply both equations. In 10, 11, and 12 and a number of the earlier ones, you only have to multiply one of the equations. So you have to be careful, look for a common multiple.